Good afternoon, everyone. Welcome to a next first Friday of the month training. Uh, Again, we find ourselves on YouTube, and at least my understanding is that this gives, without further ado, the access to such training session after live. You can look at that anytime. So therefore, that's the way to go, making these short sessions available for you, even if you cannot join live on Friday. Um, Today, we have a clear focus on what I would call the topic of design of sites for the usage of radar for perimeter security. Therefore, obviously, the integrated solution in most of the cases with video. We will not focus on the placement of the cameras. Clear focus is the do's and don'ts, let's say, with regards to radars. And then second part to look at the design tool. Third part, um, although I think this cannot be as interactive as we used to do it, I prepared three or four designs, and I will highlight why they are probably not ideal. Therefore, without further ado, starting with the background, we're talking about the radar principles and therefore the question whether or not to place a radar in a certain point or choose a different one. Topic one is the general principle of elevations. We used to say if there is a choice, choose the downhill option rather than the uphill option. I believe nowadays this is less relevant. As you know, you can tilt the radar on the one end, and second, the clutter, therefore, that is delivered by the elevation uphill, so to speak, that would be a clutter that is already making detections harder for the radar, and that's something that's not as significant. So therefore, uphill or downhill is not really the major topic, but if you have elevations that are not strictly linear, so to speak, here such a um, layer is quite interesting, and it could go up again, down again. So therefore, if you have more complex lines, then it's first of all necessary to realize that and to focus on those. Over 100 meter, an elevation of 2-3 meters is not even significant. But if you have like going up then down like a tail and then it goes up again, the key question is whether or not the radar will be able to detect in these areas. And this is something where Magos radars are very helpful as to the large vertical angle and the performance compared to other vendors that you find in the market. So therefore, you are on the good side using Magos, but still, it's a topic to be really seriously, considered. And if you need to, then you would have radars for a part, and then after such a floor building here, you would have another one pointing downwards, as example. Um, these considerations, please do them once you look at the site, especially not only via the tools like Google Maps, but as well Google Earth with the elevations. Um, Check it, especially once you're on site and you have an very updated, means real-time impression images on Google Maps and so forth. As we know, they are not always updated. Elevations are similar to next topic, which is blocking objects. Same topic here. once you have a very active client, they might have already put new containers, new temporary or permanent buildings somewhere, which you haven't been aware, let's say 2 months ago, slash obviously it would not be visible in Google Maps after just a couple of weeks. So therefore, that's something that I keep on seeing once I join you guys to a new site where we say, this is probably the end of the property. Oh no, there's a new field over there and there is a new building number 8. Nothing of that we were aware of. So these are impressions you can only get once you are on site. If a site looks as simple as our image here, probably you can do pretty much closed eyes a design only remotely with the map information that you can get. Anything that is more complex, it's always worthwhile to go and see it, if it's a paid service or not, but it definitely makes a difference. We're talking about the elevation of the radar here in the last point, which is the question of harsh winds and the tolerated movement. Very harsh wind right here. So if I drop out, then it's because of my electricity is down. We have a very strong windy day over here. We say the pole at the installation elevation should not move more than 3 centimeters. In general, there is, on the one end, if you move the radar during windy times, there is a chance for false alarms. And then second, there is a chance that the radar does not position the target exactly where it is, but just slightly left or right, as example, in accordance to the movement of the radar box, so to speak, that is currently happening. So be aware, if the pole is not very high, then usually it's not such a big issue. If it's a higher pole, either they are anyway quite massive or they need to be, slash they are already fixed with additional steel ropes. So be aware and make sure there is no large movement. Once you have poles combined with cameras, usually the guards will tell you already that it's very, very disturbing, as they see the shaking images of the camera, and that is driving them nuts. So therefore, once you hear about that, you can imagine that the radar is to be stabilized as well. What is still absolutely valid at that point, in general, these radars that we offer and radars you find in the security industry, they are performing much better on radial movement compared to tangential movement. So if you have the chance to identify the targeted direction of people coming to site, or whatever the reason for the given direction is, as much as you can, make sure that the expected movement that we want to capture is towards or away from the radar, rather than parallel as indicated with this one. So this movement will be, the person walking uphill here will be much harder for this radar to be detected compared to this position. Just make sure, and that's something that is absolutely crucial. Will it detect at all? Yes. Over time, it will detect. The question is, how much longer will it take? Or will we, at some stage, in a perfect movement, very short, maybe quite slow, will we miss the one or other? So therefore, the direction of the movement somewhat is definitely relevant. And if we have the choice, we might put actually 2 radars at a corner or whatever exact perimeter line we are looking at as example. If you can position 2 radars and they are, give or take, 90 degrees pointing away from the first one, then obviously you have a much better chance to detect movements from any direction fairly quickly. As you know, depends on the scan rate as well. So give or take, after 2 seconds, you would have a target usually. We were talking about objects, so therefore, what are the chances here if you have designs of substations as examples somewhere close to a city, then you have a forest right next to it. Happens a lot with photovoltaic nowadays as well. If the customer expects us to monitor movements in the forest, that's not exactly what radars are great at. So therefore, I never design anything like that, although we know that uh, up to something like 30 meters, we will be able to see targets under circumstances. But as you know, it depends as well on season, whether or not there are big leaves or if it's winter, no leaves whatsoever. So therefore, a very different line of sight. Don't indicate anything that we can't be really confident about. So therefore, don't indicate that we can monitor movement in the forest. If there is a forest line, if there are trees, if there are bushes, one of the questions actually which is worth to consider is, can we trim them? Will they be trimmed on a regular basis? Is there gardening service and so forth? Depends on the type of site. Maybe they might cut trees even and stuff. Not that anyone likes that, but for the security purpose, it might be required, or for other activities they anyway plan, like additional building activities or so. So therefore, question one is, if there are objects that are disturbing, can we minimize the impact? Next will be, can we therefore increase the elevation of the radar, so therefore we can look above easier than in such blocking event here. Of course, this is very relevant with regards to buildings as well. So in general, of course, we need to have an updated information. Do we plan the radar setup during the course of construction? So therefore, where will buildings be? It doesn't make sense to say everything's clear. Radar can be positioned at 4 meters, and once you start to install, in front of that position, you will find an 8-meter high building. So therefore, updated information, clear positions of existing and planned buildings, and then in accordance where to position which areas are good for a clear line of sight. Remember, radar is not an X-ray, so therefore neither through buildings nor through big tree lines we are able to perfectly detect the movements. Another very typical question basically is, can you deal with metal objects? What about fences and so forth? And in general, you can say, as we are deployed in all type of verticals, and we are doing this for quite some time now, yes, we have a lot of sites where we have fences and metal objects and so forth. So therefore, it's a matter of, can we deal with it or not? There are some better or worse positions, and that's a little bit indicated here. Example, reflections. If the radar beams right to the fence, then there's a chance of mirroring effects or such reflections. So therefore, that would trigger a false alarm if the radar points the camera over here and there is no movement. Will we have two objects or only this one? So therefore, we even lose the real movement. So these are things that we need to consider, and therefore we would position the radar, as example, very close and along the fence, looking down that line, rather than having the radar relatively close to the fence and pointing right to the fence. So these are things that we need to take into consideration. In general, we tend to say, instead of pointing the radar all down the fence, let's point it towards the area of interest. So let's say if the focus is on the internal, and here's the internal side, here's the external side, divided by the perimeter line by a fence. Then point the radar, first of all, a little bit to the inside with some 10 degrees as example, and therefore optimize the coverage on the inside. That gives us the chance, as we can see in comparison, to have pre-alarm quite significantly. Therefore, that's a matter of considering the, let's say, area of highest interest or even alarm zone, and therefore we want to capture as much as we can if possible, and if it's not narrow corridors and so on. Narrow corridors are anyway a very tricky issue between two buildings and so forth. That's not where we are really, you know, where radar as such is not extremely helpful. If you have a 3-meter corridor, a person could pass these 3 meters in literally no time. So therefore, even if we detect, it would be a detection or two, just as example. Based on that, we would not have a chance to eliminate false alarms by, you know, wind, trees, typically branches of a tree moving in wind. So therefore, we count these 5, 6 detections and say, yeah, it keeps on moving, it keeps on walking, so to speak. So therefore, yes, it's a relevant target. If I don't have the time because of the corridor is just too narrow, then you would take the risk of having many false alarms, and therefore that's not ideal. Minimum width of a corridor should be probably close to 10 meters. Then we are quite happy. Here an example how such a design ultimately might look like. In this case, a substation, very easy design, basically 4 corners for radars, and all of them pointed slightly to the outside, because the indication by the client is let's try and make sure that we see somebody, you know, attempting the site, moving towards the site, and therefore have a pre-alarm functionality. Once we have public areas like this and we use the radar for that, there is always that question whether or not this is a data privacy issue. No, if you use radars, A, they're totally safe, and B, you don't have an image of a person through the radar, so therefore the radar itself puts you on the safe side. And the next question will be from which area onwards you will point the camera. So therefore one could do this as example only inside, you know, covering the own perimeter and plot. Some general rules of thumb. Minimum installation height 3 meters plus for the 250 meters, and it goes 6 meters, 12 meters across 500 and 1000 meters. In general, you could say if the focus is on the very far away of the radar detection capability, the higher the radar is probably to be mounted, and that's simply to do with the line of sight. And if you have the focus on very close to the radar, then you might go with lower elevations. Typically, I would never suggest an elevation below 4 meters as well, for the question whether or not an intruder could easily access the device. So therefore, anything I ever recommend is above 4 meters. Line of sight is the major topic as well of the buildings and other objects in between. So therefore, very simple rule: what you can't see, the radar can't see. It doesn't work like the human eye, but it's a very good check. So therefore as well, if you want to cross-check with us, take pictures from the position where the radar is mounted. If you have subcontractors putting the poles, and you would not be on site, make sure they will share a photograph before they start digging, so to speak, because one more time, things might have changed, and the end customer did not update us, you, the plants, whatever. And hence, only at that moment where the subcontractor is about to dig the hole and put the beton for the like the concrete for the pole, that's the moment where it's 5 minutes later. It's too late. Pole is fixed, and it will be very difficult to move it another 2 meters just because an object appears bigger than we all did expect before. So if you can get images last second, so to speak, I want to motivate to do that and get those, just to look at it, say, yep, it's as expected, thank you, and now start to build the pole constructions. Um, if we say it's not comparable to the human eye, then here is this additional hint. Yes, if we can see through a fence, um, as there is holes and there is light coming through and whatnot, does that exactly work the same for the radar? No, it will not. On the other hand, if there are lines of obstacles like trees, then while we might not see anything, the radar might detect. So it is not exactly the same, but it's a good indication. As I say, what we can see will most likely be seen by the radar as well. Just be careful with fences, as we said. Otherwise, that works quite well. Um, Metal obstacles do disturb more than wooden or other materials, so therefore that's as well a topic. If it's old surfaces from buildings as well and so forth. Um, Again, it's a matter of direction of the radar and of course the absolute position. On the other hand, ultimately you could say, if you are doing a site survey and you have a demo kit with you, try a position or two and see if there is an impact. Yes, and ultimately, if there are some impacts, we can still, in the fine tuning, deal with those issues and reduce them. So a lot is possible at the end of the day, but the key exercise of the good design is to avoid as many problems as you can in that early phase, and therefore have a successful project and a happy client at the end of the day. Um, I skipped this one. Here, just again, a 3D model of the lobe of the radar, so therefore you have a bit of an idea. That's why we do this ellipse-shaped design in the tool, as you're used to, because we are using the bird's eye perspective and say that's basically a horizontal cut. This would be therefore the view of that, and you see there's the additional lobe as well with regards to the point of installation detection. Same view from the other end, so to speak, and an overview about of the different radars. Here, basically, again, the reminder that with the 250 and the 150, it's either 150 or 250 meters for any object, and the other radars we differentiate slightly. Smaller object, we are conservative and call it 400 or 600 meters. Larger objects will be detected as well in longer distance. This is kind of the minimum, you could say. I did with Scepter C, so 500-meter radar under not ideal conditions. I did detect human up until 650 meters. So let's say in most of the cases, these are very, very conservative. Opening angles you are aware of. Little bit um, about the setup. So in general, Google is our friend, we say later, I believe. Anything you can get, photographs and whatnot, anything would help to understand the site. as much as we can understand on the one hand strictly the perimeter line, on the other hand an area or maybe even more areas of special interest. So what are the hot zones, and where are we on the outside layer of the onion, so to speak. Obviously, threat zones, intrusion routes, pointing exactly to the same topic. Covering zones as pre-alarm. So therefore, what's the maximum coverage? From where onwards should we track? Yeah, that's the most important considerations. And as you know, ultimately, if we go with existing cameras as well, uh, combination of planned camera installation points, but as well existing ones. As long as we can use those, it's obviously a matter of efficiency to do so. So therefore, have a clear position of those as well. Rest is clear. I mean, basically as well for cabling and where a mass server would be and so forth. If we look at the Mars software, and we will see the design tool in a moment. In general, on the one hand, we would like to have a clear perimeter line. So therefore, let's start with the perimeter and say this is the general object. And then in a different color, you might say area 1, area 2, whatever. And then in accordance to such a perimeter, come up with a design where you allow overlaps, where you make sure that we are not maximizing the or exploiting the max distance, so to speak, just to be conservative on the positive side. If budget restrictions come to play, then then everything's a compromise at the end of the day. So therefore, focus on the most important areas with very good coverage. Allow wider coverage in those where it's pre-alarm only. Just as a general rule, obviously this is basically really side by side. So there's not much we can generate with or generalize with such ideas. Ground elevations, 3D image, we spoke about that already. Here's just another example that maybe there are obstacles that appear very small. Maybe you can't even see those. Maybe they are temporary. So therefore, the real impression you can only have once you're on site. And we've been there. We've seen like little bushes, and 2 years later, when the installation happens, they were much bigger, and the customer was wondering why the radar isn't performing. So these are the tricky parts of, I guess, ultimately the business we are in, not only because of talking about radars, but in general, perimeter projects can have a planning cycle of a year or two, and in that period of time, a lot of changes can apply. So therefore, that's what we need to be very aware of, and I guess indicated before. Especially trees, bushes. Obviously, they look very different during the different seasons. All those things to be considered. The zones we will talk about a bit later. Basic steps in mass. So therefore, basic steps in mass. Therefore, draw that line. And if applicable, here in these examples, the positioning of the riders obviously along the perimeter line to focus on the real perimeter. And what else? Of course, in the design, you already direct the radar, so you put an azimuth, and you can definitely indicate pre-alarm and alarm zones already. And as I said, we look at the design tool in a little bit. and I want to show you again how to share your designs. Then we can upload, play with them, challenge the one or other thing, ask the other one, ask the one thing or another, and together we will come up with a mature plan for the site. That's it from this part. It goes accessing design software. So let's do this. Wait, I need to pull. I want to pull this one down here. Zip. So here is our partner portal. Oopsie. Here's our partner portal. Um, Once you have a login, you can use all those different areas, downloads and whatnot, license manager for those that are managing the licenses by themselves. Knowledge base is quite useful as we have the camera models and integrations listed over there, and down here you find the site design tool. Once you have used it and later you want to continue working and you have problems to enter, just close the tab of the design tool that popped open and refresh the partner portal page. Most likely you will be asked to confirm your login data again, and then it's up and running. It's basically, as we have so many users, that we refresh occasionally and therefore kick you out, so to speak. This is a little bit of a change what happens. Once you open or you click on the design tool, you land at your latest design. And I want to talk about the design tool a little bit, what it offers. Let's see how quick I am. Your initial starting point will be somewhere in the ocean. So if you don't see anything but blue, then most likely you did not define or change any position just yet. And therefore, the first thing to learn is about this area. As you know, this is very much like the mask tool itself. So therefore, here in the main area, we can first of all open and close the tools. Then second, we can choose different map sources. And third, we can activate the different symbols and areas and so forth for the user interface, so therefore they are shown or hidden. Here on this side we have a measure tool, so point to point you can measure a line, and if you open a polygon, then basically you get the square meters as well. This is the function sometimes very helpful during a design. Once you define the home position by finding your place, you can either type a city name as example, or you type or full address, or you type the latitude longitude, so the GPS data, jumping to whatever position. Let's say I arrived right here, and then you can, with a right click on the little home symbol, with a right click you can confirm the change of your home position, and therefore wherever you go from now, you can jump back to home at one click. Basically both latitude longitude and second with regards to the zoom level as well. Do we have something similar? Yes, we have presets as well. So therefore, if you want to work with 2 or 3 or 4 destinations, you can basically save them all as presets. And wherever you work currently on the design, this one you're gonna save again as the home position, because not only that the home position is easier to reach with one click, otherwise you need to theoretically do even 3 if they are hidden, 3 clicks and come here. But as well, once you have a home position defined, this is where new radars will appear. So therefore, if you work across all Europe, then it's quite helpful to use the home position. Otherwise, your new radar that you want to add in Switzerland lands in Poland because you were working on that yesterday, and then you need to drag the radar all through Europe, which is not very comfortable. So therefore, that's the main function of the home position. Home position is the initial view, and home position is the position of a new sensor that you add, and then you can, in the edit mode, move and change that position. Let's do this quickly. Let's grab radar. Let me see this one. Mr. Right click again tells me the name of that radar. So 15.8 something is this one. And here's the delete, here's the edit. Let's go edit. And now I can take it and move it along, or I can use the keyboard as well. As most of you know, using control and the arrow keys moves it by 10 meters. If you keep shift pressed, it moves it by 1 meter. And it's the, what is it, like square brackets for the azimuth angle, as well with shift 1 degree, otherwise 10 degrees. And if you have a different keyboard, check it. I think in German it could be where you have the Umlaute. Yeah, otherwise check with support maybe. I don't know it with every like national flavor of keyboards. This is how you can edit radars. Obviously, using the plus here, you would add another radar. It's not necessary in the design tool. It's not necessary to add IP addresses. It's automatically added, and it's design only, so they will not work. That's, by the way, as well, one example when we say, can we use a design and copy it to the mass world of the real installation? Well, of course, you would need to do several editing steps afterwards. That is login data for the cameras, it is the IP addresses, and some other things. So these are not real, so to speak, because the design tool is for image only. Yes, okay. So let's go back. This is how you can add and move and edit a radar. And do I have buildings? I think I have buildings later, so therefore we can already use some of the examples. I target to not take longer as 60 minutes, so therefore let me already start with the examples. And as I said, it's a bit unfortunate that this session is, at least to my understanding, not as interactive as we used to do this in Teams. So therefore, I will, good for you, I will not ask questions and ask for your input. I will comment myself on those designs. Okay, so if this is it D1? No, sorry, what did I prepare here? Yeah, D3. Okay, let's go with, wait, we start with AT1. Where is it now? Sorry, resets 81. Let's start with this one. What do we see? We have a design that works with one radar. There is a nice, let's say, logistics site or something. So in general, probably a good site for radars. Now for this design, I hope that you guys come up with one or other question and idea. So let's start with the position of the radar. That's maybe minor, but nevertheless, where is it positioned? Is it still on site actually, or is there a pole, or how come it's in this little bush line there? That's probably something to look at. And then second, will we cover what we are supposed to cover? And third, what about the objects themselves? Do we maybe have some blocking here? Well, obviously we will have a bit of a blocking with these buildings, and look at this one. So therefore this one cuts off already almost 50% of the of the line of sight. And here in green, I indicated the targeted areas, or let's simply call it two corridors that should be monitored. And you can imagine that the radar here will have maybe a good chance in the beginning here, but a very bad chance over there. So therefore, this is definitely not a good design. In between those buildings anyway is something that one can question if radar is the right choice of monitoring this. Would we better focus, as example, on that area, just to name an example, or the rooftop areas and so forth? But narrow corridors, very long, and then only one radar somewhere in a non-good position is probably not the way to go. So did I hide something? No, probably not. So you see, these are this is a first example of saying, well, that's not a design that looks final or professional. And here I would first of all probably invite and say, why don't you use the tools that we provide with our design tools? So therefore, start to draw those buildings. And if we just take the first one, more or less, then we can already see an impact of such such an object. And if we go to the edit mode of this radar and move it over here, then we will see that the impact is gone. Well, obviously there are a couple of more objects that we would like to draw in this example. If this would be a project and we would not focus on rooftop only, I would like to know the distance here in between these buildings. That will be extremely important to understand. And once it hits a minimum distance that we are comfy with, we might say, okay, let's have two radars, one in this direction, one in that direction, and the same here. So four radars instead of one. That could do a job there compared to such a wrong design. Next example. Hopefully this is somewhat useful. So here we have an area of a whatever company, let's call it. I think they invested a little bit in solar. And we want to focus very much on the area on the western side, just to better illustrate. Here's already an area of interest defined, and we have a design approach where we go with a bunch of radars, good coverage, and line of sight is not a topic here because we didn't draw any buildings. What would be your thoughts? On the one hand, we have radars all across that building with a lot of overlap. So therefore, question one, does that really make sense? Why isn't any radar Why isn't any radar pointing along the building to cover the area next to the building? Then second, what's with the impact of both this movement over here, but as well the elevation? Is there a tunnel? Will we see through? Will we cover via, like above that, what is it, the train? What happens if there are trains driving and so forth? Here are buildings. Will we see anything with this radar over here? Well, very, very, very limited. So does that all make sense? Yes, no. Just a quick example. And another point I've got here. If you do these designs with a design tool, let's say, as it's an image only, we can forgive a couple of shortcuts here. If we do this in the real mass, then as well the positioning of the sensor, and you remember the calibration, is extremely important. If you look at these three sensors, I wonder what is it supposed to be? Are they all like on the surface, like on the side of the building? Or if we especially look at this one, uh, is it really to be over here, or can we move it over there? So that is probably a distance of 2, 3 meters. Let's see, give or take 5 meters. Uh, And if I, in the real system, if I position the radar 5 meters away from where it really is, you can imagine that it has an impact on the calibration quality, so to speak, and the calibration steps. So first of all, let's be precise. If it's here at the corner, use zoom levels of a very, very intense kind. Coming up with a bit of delay, I'm watching that. So um, use very exact positions by high zoom levels, and then we are, your calibration work will be much easier. Um, all right. Again, all these overlaps. Is there better designs for the for such a site? Here, as example, we could think if I start off at a good corner and I tilt the radar down here, probably the single radar will have very good coverage for that main area over here. And the idea after a tunnel to still detect over there is probably something that is theoretical only, and in practice we would never suggest anyone to design it like this, besides whether or not this is private ground and so forth. So that's only an example to play with that blocking, expected blocking of both a bridge on the one end, and then probably trains traffic on the other hand should be excluded at least, and whatnot. So again, just another example. Here I have a third example. Um, this is a wall, and we want to cover, again, we want to cover the green area over here. So therefore, I use the wall and I point one to the south, one to the north. Is that a good design? Well, on 2D maps, it looks quite okay. If we zoom in a little bit more and we understand that this is not a standard wall, but I think several meters, several hundred meters high, like from probably down here to up here, it's close to 300 meters, I think. This is like an artificial lake. Here's the blocking wall, and here's the, um, you know, here's the area that is where the water is kept away. So therefore, the elevation here is so massive that with a very forgiving design of saying, well, I have that coverage, in reality that would not do anything, because of the movements over here that might be relevant are several meters, maybe 100 plus meters beneath the area where the radar would work. So therefore, this is an example as well taken from an existing project, not this one here. But if I need to monitor such an object where I know that I have at least 10 plus or maybe 50 meters difference elevation by 3 steps, so to speak, or if I want to see the movement on such a street here, then the design on Google Maps does not really help us. We need to look at this in detail, and we need to understand, is there any pole that we can set where we can cover 2 sides, or is the elevation that extreme that basically line by line you would need to go with a single radar? So this is an extreme example to illustrate the elevations and the necessity to do this with the right focus. Here, the design on Google Maps simply does not make sense. We need to very, very detailed, understand what it is the customer wants to cover, and then do this really walking, I guess, these areas. Otherwise, you can only have wrong assumptions here. This one we can skip. It's a similar topic along such a river. That's only what maybe 3 kilometers or so. Yeah, 3.5. However, a massive elevation, then you have a line of tree and whatnot. So therefore, and ultimately even half a village here. So this design does not make sense whatsoever. We need to do this in a more detailed level. And again, if there is a level of complexity, then you need to do a site survey, and we need to understand exactly these areas. And 1,000-meter radar looks great for the coverage, but it will not work across different elevations, forest, not forest, buildings, and whatever have you here. So just to make you aware, here is almost last example. Uh, this is a project where you could imagine that there is a high level of complexity, and you have water surface, and you have building areas and small uncovered areas. So such an object, on the one hand, you could say, well, this probably can make a lot of sense with regards of the performance of radars, especially once you have water surface where the uh, water surface where optical instruments fail. So therefore, here a 2 kilometer plus line. Forget about accidentally I closed it. So 2 kilometers plus line over here, we can probably work with very well. Bunch of meters into the water surface, no problem. We can cover that with radars. Here in between, there might be areas where radars, maybe especially the 150-meter, can help and makes a lot of sense. And then other areas, most likely you need a different technology. So if I just took this one here as an example to say, if there is with no very educated eyes, if there is a level of complexity that doesn't really allow us to make a very precise drawing here, this is a site where I believe without site survey, walking and understanding and looking at the different objects, it would not work. So therefore, that would be my example to say, here we need to go, here we need to check, we need to learn from the client. Should this be inside? Is that inside? And do we have cameras and whatnot? But the radar most likely helps here on water surface, and then only in open areas. Last one, back to here. That again is an example that is taken from, let's say, quite a real project, and it's a bit of unfortunate. So therefore, here the indication of, I have several radars pointing to the same direction. I have a lot of overlap, so therefore, does that really make sense? And then in this case, I'm monitoring most of the coverage areas, like say inside of woods. So what is it I'm really trying to achieve here? And it happens. Sometimes the customers don't really know what it is they want to achieve. So therefore, this is where we need to help, and we need to come up with a good concept that adds value. So in this case, what about the port area? What about this area being relevant, yes or no? But radar can't see through these woods. So what is it we would like to focus at? And then again, from the design perspective, look at this radar. It's not on the building. It's not anywhere close to something. Why not here at that corner? Why over here? What's the reason? If the coverage is for this street here, so to speak, okay, no problem. And then it's just same thing here. It's set up in a way that you could say, yeah, roughly okay, it's at that building, but zooming in, we see it's several meters right in the middle of the street. So therefore, this is unlikely that you will have a pole over here. So again, in design, not so brutally important, but let's get used to you doing the positioning of the sensors really precisely on the corners, on the surface, or wherever there is poles or existing light poles or something. that will make sense, because if we do these rough jobs, especially in the live system later on, the calibration will be a nightmare. So that's just another example. Here you see same problem, the same mistake, let's say, that repeats over the different radar positions here. And then one more time, the general concept of what is supposed to be covered with the radar, what's the target of using this radar integrated solution. In this design, it would absolutely not be clear to me, and we would probably come up with something very, very different, focusing on areas where we can definitely help, like these plain areas, water surface areas, and then this, if it would be necessary, you might have a fence with a line detection or a climb over or something, but you would not try to do such a design with radars. Now, after a bunch of very bad examples, I didn't plan to close off with a good design, but maybe that's an exercise in the face-to-face discussions in the coming trainings with your organization, or looking at your challenge with regards to a site to be covered. Hopefully this was somewhat informative. Again, we went through a little bit of theory, where to position a radar, what objects, what metal objects to take into consideration, and then we looked at the design tool as such, a little bit about the functionality here, and last but not least, these couple of examples. I guess what I really try to highlight is come up with a design that really makes sense and shows the benefit of the radar in areas where we can definitely help, instead of doing something like this. Second, start to work very precisely with regards to such positions and so forth. Third, use the different areas. So mark a line that is the perimeter, and then add areas, an area or two, whatever, to say this is pre-alarm, the other one is alarm. You can indicate that already. You can use those user interface show or not show symbols, and talk it through with the customer to say, look, this is where we plan it. It will have such a coverage, but because of buildings that are missing here, there's an impact on the line of sight. So you can basically step by step talk that through together with the customer as well. I think this is quite helpful. And last but not least, if you start a design, if you're done with the design that you want to discuss it with us, either we do this in a live session, or you can here with the cloud symbol, you can download your site and share it with us. We can upload it. It will appear exactly like this one, and then we can do modifications, download ourselves, send it to you, and say, here we did a couple of modifications and we want to discuss them. Like this, we can cooperate as well. Therefore, this little cloud symbol is not only to save and organize your different designs, but as well to download and share them with our technical support, myself, with Andy. You choose, and then we can work on it and challenge if we can come up with something even better. Last remark on this little cloud thingy. Whenever I do a new design, then I would save the existing. So therefore, here I did or did not any changes, doesn't really matter. I would go save as, and the name that you've given initially comes up again. I would confirm, and then I start a new site. Otherwise, there is a certain risk, while this is cloud-based and saving continuously. Once you just go and open a new site or upload something or whatnot, then you might miss the last changes. So therefore, I know it doesn't sound very logical, but to be safe, I always go save as the existing one, and then I open a new design, or I load an existing one to continue working. That's a little, maybe it's even a bug, but it's not a big thing as long as you are aware. So therefore, once you leave a design, save it again, and then you're on the safe side. Otherwise, it's a bit annoying if you plant another 10 raiders and then you have to start from scratch. Happened to me, hence I'm sharing. And with that little remark and tip, I'd like to close it. Hopefully, the design tool is really helpful to you, and those that have starting problems or whatnot, you might look at this session again and or contact us. We are here to help. After this little webinar here, I will do exactly that. Call a colleague and ask how we can ensure that he gets started in the right way. Many, many thanks for listening. Thanks for joining the Friday webinars. And I'm looking forward to seeing you in give or take a month from now. Have a great weekend ahead and talk soon.